Okay, so we're reviewing for the final, and we're talking about exponentials. Exponentials are the kind where there's an x in the exponent. And this top one is a really simple kind. It's called evaluating. If you're evaluating something, you're just taking a value and sticking it in. So if they say x equals 2, you just have to stick in a 2 right there. In your head, quick, do the right order of operations, and what would the answer be? 12, because this would be 2 to the second is 4, and then 4 times the 3 makes 12. All right. This next kind is a recursive. Do you remember those? And then they want you to write it as an exponential. That's also known as an explicit. I happen to know that that's the word that they use in the test, so I would write that one down. Explicit means exponential. All right. And here's the kind of function they're talking about. Y equals, and do you remember the kind where you'd have a starting value here? And then the ending value is here? And then the rate goes in there? And then the years goes there? Remember all that? All right, I'll give you an example one here. So we had the starting value was what in this problem? 8. And then I have what's the number that's going to be multiplied every time. See right there? 0.5. To the what? What goes here? This is called an exponential, so it needs an x in the exponent. Okay, there you go. Now you may remember these being, I kind of like did this little annoying thing where I said you couldn't just leave it like that, though. You had to write it like 1 plus or minus something. Do you know what I'm talking about? And that helped you to remember that it was either an increase or a decrease, right? And in this case, if I write it as 1 minus 0.5, you can see that it's a decrease or a decay of what percent? 50% decay. Okay? So if I start with an 8 here and I actually do this and I multiply it by 0.5, the next term would be what? 4, and the next term would be what? And the next term would be what? And that's called 50% decay. All right. So this one. Actually, you know what? I want to do another one like that with you to see if you really got it. You try this one. U sub 0 equals 20. U sub n equals U sub n minus 1 times 1.3. I'd like you to write an explicit function for that one. I'll pause while you do. I'd write 1 plus 0.3. Yep. Then if I asked you, is that growth or decay? If I write it the right way, like I did, it's easy to tell. What is it? Growth by what percent? 30%. All right, if instead it had been like this, would it be growth or decay? And what would the decay percent be? 70%, because you could rewrite this as 1 minus 0.7, and that would make it easier to see that it's 70% decay. All right, moving on. Wait, there was a problem I skipped back here. I want to get to there. Nope, I don't like that one. I forgot. I tried in a different class. It just gets weird. Okay, what is the y-intercept and the growth rate of this? So the growth rate, we just talked about that a lot. The growth rate's right in there. What is the growth rate on this one? 50%, okay? Because we're written it as 1 plus 0.5, so 50% growth. The y-intercept, repeat this statement, or say it after, say what's supposed to come next. The y-intercept is where x equals 0. Okay, so if x equals 0, I just plug that in here. Figure it out. What's the y-intercept there? 7. Because 1.5 to 0 is just 1, and 7 times 1 is 7, so the y-intercept is 7. But there's a smarter way to write that than 7. Is it 0, 7 or 7, 0? Yeah, because the y-intercept is where x equals 0, and that's where x goes. So. All right, and then the growth rate we already said, 50%. Okay, this next one is talking about a transformation of a parent. y equals 3 to the x. So if there's the graph of it, do you remember these where they always went through this spot, but as they got steeper and steeper, it was because this number, the base, got bigger and bigger? Like when 4 to the x got steeper and 5 to the x got even steeper. And they always went through this spot. And I hope you remember how we can like figure that out. If they always go through this spot, it's because x equals 0 at that spot. And then I go back over to here where it said y equals 3 to the x, and I replace x with x equals 0. See what I'm saying? If I have a 0 there, it doesn't even matter what this is. It could be 55 to the 0. It's always going to equal 1. That's why that's always 1 as the y-intercept. Unless you do something like this to it, and you stretch it and put a stretch factor in front. Okay, this one right here, compared to this one right here, does it look like it moved left, right, up, down, or got stretched, or flipped? I think it moved left. How far? So it was 2 to the left. If it used to be this, and it went 2 to the left, what should I do? Plus 2 up in there, because that's the left-right stuff. Okay? Everybody figure out what happened on this one right here. And write down what you think the answer is. Remember, you're comparing it to this one. I'll pause while you do that. Okay, so there it is. Negative needs to go in front because we flipped it. Up, down, flip. Raise your hand if you had that one right. Okay, good. I think that's enough of those. Next kind is evaluating. We talked about that at the beginning. And it says the key at the end, x equals 5. Just got to go back in, slap in a 5 where you see the x. Do it in the right order. What comes first, multiply or exponent? Exponent. Got to do this part first then. All right. This one says record the 3 terms of the sequence. First term would be, well, look at this. It tells you the first term. What is it? 16. The second term I get from looking down here and knowing that, oh, I guess I got to do what to the 16? Multiply it by the 0.75. So then it's going to get smaller, isn't it? Then you'd write an exponential equation for whatever this set of terms is giving you. And so basically you start with this starting value of 16, and then you do that. What do I do each time? I'd write this, 1 minus 0.25, and that's the same as 0.75. And then I put it to the x. I need an x in the exponent, so it's an exponential. You get that? Okay, on to the next part. Same idea, it's just giving you a exponential and asking you to write a geometric sequence for it. So it's like backwards. It's giving you this kind of a thing, and then it wants you to write one of those kind of things. I'd like you to try that while I pause. So since the starting value was 3 there, we go u sub 0 equals 3. And then this 2's got to come in handy somewhere. U sub n minus 1, and then we use 2, but I would say 1 plus 1 to the x. Oh wait, that's an explicit kind of formula. Don't need that to the x. And that would just remind me that my growth rate is what? 100%. Because a lot of people see a 2 and they think it's 200%. It's not. All right, this one is just talking about the ratio of the second term to the first term. So you just divide these two. Once you divide those two and you get 0.75, then the ratio is 0.75. And then is that an increase or indicating a decrease? Decrease of what percent? 25%. Because you could rewrite this as 1 minus 0.25. All right, moving on. This one, as I see it, it looks like it moved like this. Doesn't it look like those are about the same distance? Then it was a shift, not a stretch. Okay, it was a shift of 3 to the right. And this one, notice how it goes up this, but up that. The distances are not the same. What does that imply? It's a stretch. And the stretch factor, it went from 1 to 3. So what would you multiply by? 3. So the parent is like this, and I multiply by 3. I put a times 3 in the front. All right. And then there's a few of these. I'm going to pause for a second while we do a few. Okay, there we go. And the next one, it's negative is not in parentheses, so it's negative 4 times 4 times 4, which is negative 64. If that negative had been in parentheses, it would be negative 4 times negative 4 times negative 4. Either way, in this case, the answer would have been negative 64.